Hello, welcome back. Continuing our series on linear equations. This is part 2 of word problems involving linear equations. So if you haven't taken a look at part 1, and if you haven't taken a look at basic, go ahead and pause this. I put the links in the comments. Take a look at those and then come on back. This is part 2. Okay, let's take a look. All right, so here's our first word problem of the day. Eric enters a hot dog eating contest. He is given a pile of 100 hot dogs. He can eat 2 hot dogs per minute. Write an equation to show how many hot dogs he has eaten X minutes after the contest begins. Now write an equation to show how many hot dogs he has left to eat X minutes after the contest begins. All right, so first let's note two hot dogs per minute. That's our constant rate of change. That tells us linear. Linear says let's get our slope-intercept form on the page, y equals mx plus b. All right, write an equation to show how many hot dogs he has eaten X minutes after the contest begins. All right, our constant rate of change is those 2 hot dogs. So y equals 2x plus b. And then b, that's our y-intercept. That's what is happening at 0 minutes. So when the contest hasn't even started yet at 0 minutes, how many hot dogs has he eaten? Well, he's eaten 0. So our equation to show how many hot dogs he has eaten X minutes after the contest is y equals 2x, right? X number of minutes times 2 hot dogs per minute tells us how many he's eaten as the contest goes along. Now, write an equation to show how many hot dogs he has left to eat. Well, we know he was given 100 hot dogs. And we know that as the contest goes along, he's eaten 2x hot dogs, where x being minutes. So that means to show how much he has left, we would take our 100 hot dogs and we would subtract the amount that he's eaten. Y equals 100 minus 2x shows us how many he has left to eat, whereas y equals 2x shows us how many he has eaten. Okay, so there's 2 options there. All right, our next problem today. Mac the mole lives in a burrow underground. He begins to dig down at 20 inches per hour. After 3 hours, he is 77 inches underground. How far below the ground is Mac's burrow? So let's give ourselves a picture here. I think that pictures can be really helpful. So there's the ground, and there's Mac's little burrow. And we want to know how far underground his burrow is. And then we know that after 3 hours, he is a total of 77 inches underground. Now, we also know that he dug for 3 hours and he can dig 20 inches per hour. So how many inches has he dug in 3 hours? He has dug 60. So if he started at his burrow and dug 60 inches, and we want to know how far that burrow was underground, then we take our total distance he is underground, 77, we subtract our 60, and that means his burrow is 17 inches underground. Now, let's say this problem went on to say, write an equation to show how far he is underground at any number of hours. All right, linear, 20 inches per hour. Y equals mx plus b. I want to know how far he is underground. So I don't need to worry about negatives because I've already defined it as how far he is underground. So that means I'm taking the negatives out and I'm defining travel underground as being positive direction. So I know that he starts 17 inches underground. So that's my B. And I know that he travels 3 that's our 3 hours. I know that he travels 20 inches per hour. So that's my M. So Y equals 20 x plus 17. And let's say I want to test that out. Let's see if in fact, after 3 hours, 3 times 20 is 60, plus 17 is 77, and that checks out with my info from the problem. After 3 hours, he's 77 inches underground. So we started with a picture to help us understand, and then we were able to take our linear equation and use that picture to help us fill in our B, our starting point when our time is 0, and our slope, our constant rate of change. All right, now, hold on to your horses. You ready for the big kahuna? Here we go. Sam has a lawn that is 650 square meters, and he mows his lawn at a constant rate of 10 square meters per minute. Julie has a lawn that is 700 square meters, and she mows her lawn at a constant rate of 12 square meters per minute. Write an equation to express the time at which Julie will have less of her lawn to mow than Sam will. And by now, probably your eyes are whirling in your head because of a couple of things. First of all, we've got 2 people doing things. Second of all, we've got amount of lawn left to be mowed. So we know that that's a twist on the initial setup. And then finally, I want to know when one person has less of something than somebody else. And so I know that involves like greater than equal. This is all new stuff. We got this. Okay, let's take it one bit at a time. First, let's just express what's happening with Sam. Sam has a lawn that is 650 square meters. That's our B. And he mows his lawn at a constant rate. There's our info for M. So we know that our M is 10. So we know that our MX is 10X. Now, if I want to know how much lawn he has left to mow, that means I'm taking the amount of lawn he has and I'm subtracting from it the amount he's mowed. And so this expresses Sam. Now let's do the same thing for Julie. She's got a lawn that's 700. She mows it at 12 square meters per minute. So I know the amount of lawn she has left is 700 minus the amount that she's mowed. So that's Julie. And finally, I want to know when Julie, that's this, when Julie will have less of her lawn left to mow than Sam will. So I'm saying I want to know when the amount Julie has to mow is less than the amount Sam has to mow. All right, and now we have an inequality. So as per always with this stuff, we need to get our numbers on one side and our variables on the other side. So I'm going to start by subtracting 650 from both sides of my equation. And this is what's called consolidating like terms, right? 650 minus 650 goes away. This minus sticks around though. That doesn't disappear. So I'm left with negative 10x on this side. And then over here, 700 minus 650, that's 50 minus 12x. And then my less than sign hasn't changed. All right, now I have x's on both sides of the equation. So I'd like to get them on the same side of the equation. So again, as per always, opposite operations. This is a minus 12 here. So to get rid of it, I'm going to add 12 to both sides because of course I can do the same thing to both sides of my equation and it will stay the same. So those guys cancel. I'm left with 50 here. This less than doesn't change. And negative 10x plus 12x leaves me with 2x. And then my final step is I want to get x by itself. So opposite operations. This is 2 times x. So to get rid of it, I do the opposite. I divide by 2. 2x divided by 2 leaves me with just x. 50 divided by 2 leaves me with 25. So what this tells me is that when time is greater than 25 minutes, Julie will have less of her lawn still to mow than Sam will. Wow. So that was a lot of working, but really, we got it. The one thing I want to remind you, it didn't come up in this problem, but let's say we had done our mathing, and let's say this sentence here had said 50 is less than negative 2x. So our step would be to divide by negative 2, and whenever you multiply or divide by a negative with inequalities, that's the moment at which you flip that inequality sign. You would have to write it in the other direction. All right, so the thing to remember is when you multiply or divide by a negative number, you have to flip your inequality sign. But that didn't come up in this problem. All right, so that was 3 very different kinds of word problems, all having to do with linear equations. So go take a look at part 1, take a look at part 2, go back and take a look at basics for a refresher, and you're going to be all up to date with how to do linear equation word problems. All right, keep working, keep your chin up, and as always, keep mathing.